Okay, so let me start. Hello everyone. Again, this is Seungryong Kim. This week we are going to talk about the Python tutorial and our project one. Okay, so before starting, let's recap what we've done so far. In last Monday, we introduced Python, which will be our platform to implement our full project. So we will have project one, the due date on next week. Next week, correct? Okay, so let me check. So yeah, today will be the next week. Python is the high-level and dynamically typed multi-paradigm programming language. So Python code is often said to be the most like the pseudocode. So it's very easy and intuitive. So you can easily follow the function or the rule in the Python language. So before starting, I said I told you take an official Python tutorial at this this link, right? So for this class, whole code will use the Python 3.7. So you can check your Python version at the command line. So yeah, so we can install the Python here, and Jupyter Notebook as well in your CMD or your terminal. And you can open the Jupyter Notebook. You can see the following screens like this. And there are a few function summary. First one is that we can create the directory, follow this kind of instruction, and create the new notebook or the new Python file. And yeah, there are two concepts, the kernels and cell. The kernels means the computation engine that executes the code contained in a notebook document. So, and cell container for the text to be displayed in the notebook or the code to be executed by notebook kernel. So yeah, so there are two kinds of the cell. The first cell was the code cell containing the code to be executed in the kernel. So we will see this one today. And markdown cell contains the text formatted using the markdown and displayed each output in place when it is run. So okay, so let me check. Okay, so and there are many interfaces to use the Jupyter Notebook. So please try to push the button. I mean each button, so you can easily understand the functionality of each button. Okay, so yeah, here was the example. Okay, so today we will start the basic rules in PyTorch. I mean the Python. Okay, so let me start with the basic data types. Basic type in numbers. Okay, so from the numbers. Okay, so like most languages, for example, like the C or the C# or the C++ or the MATLAB, the Python has a number of basic types. I mean the basic data types, including the integer, float, Boolean, and string, something like this. So first of all, the number. In numbers, integers and floats work as you expected from the other language. So today I will show some example. Okay, so can you see this screen? I mean the Google Chrome website. Can you see? 다 혹시 보이시나요? 요 지금 화면 제 코드 떠 있는 거. Okay, so today you can just briefly or in high-level understanding of this kind of the rules, and then you can implement these kinds of the this kinds of the code by yourself. Okay, so today I will just briefly show you the basic rule. Okay, so first of all, the integers and float work as you expect it from other languages. So we can define x is equal to 3, then we can just print the x and x plus 1, x minus 1, or the x multiplication by 2 or exponential and x is equal to x plus 1 or the x is equal to x times 2 or something like this. So we can easily do like that. If we change the number like this, yeah, the result looks like this. And the second data type is the Boolean. The Python implement hold the usual operator for Boolean logic, but use the English word rather than symbol. Something like this one and this one. So, oh, by the way, by pressing the Control plus Enter, you can run this code. I mean this part, like this one. So when t is the true and f is a false, then t and f is going to be the false, as you can see here, and t or f is going to be the true because the t is true and f is false, and not t is going to be false, and t is not equal to f. It's going to be the true, right? So this is a Boolean. It's very easy. Python also have the great support for the strings. For example, we can define the string like this one, hello and word. We can print the hello and length of this string as 5, and we can concatenate these two kinds of strings like this one. Right, and then we can merge the different kind of the data type, for example, like the string, and integer. So the output is going to look like that. So in this case, in our case, okay, let's say this is deep learning like this one. So we can make any kind of strings in Python, looks like this. And in Python, there are several built-in container types. For example, like the list, list, dictionaries, set, and tuple or the tuple. First of all, a list is a Python equivalent of the array, but it's resizable and can contain elements of the different types. Let me show some example. Okay, let's define the list. Looks like this. And if we print this list, xs and second element, third element of the xs, it's going to be looks like this. By the way, in Python, the first element starts from the 0. I mean, so xs0 is going to be this one, this element, first element. And then negative index comes from the end of the list. So for example, xs minus 1 is going to be 2. So or xs minus 2 is going to be 1. Second element, like this one. And then the list can contain the element of the different type. For example, the string type. So new list is going to be looks like this. Or we can add a new element at the end of the list by using the append the function, something like this one. And the result looks like this. And yeah, we can remove and return the last element of the list by using the pop function. So the result is this one. Okay, so it's very intuitive. So by the way, if you have any question on this kind of the code, so please let me know. Maybe it might be very easy comparing to the other language like the C or the JavaScript or the even MATLAB. So it's very intuitive and it should look like the pseudocode. Okay, so In addition to accessing the list element on an at a time like this one, Python provides a concise syntax to access the sublist. So this is known as a slicing. Okay, so here's the example. We can make a list from 0 to 5 like this one. And okay, so this is the output. I mean, this is a nums variable defined here. And we can access or we can get the slice from the index 2 to 4. 2 to 4 means from here to here. Okay, so please remember the index starts from 0. So 2 to 4. So 2 to 4 is going to be here, but please remember the last number, I mean the last element is going to be exclusive. So the result of this syntax is going to be this like this, looks like this. So if we considering like this one, we only access this element, and if we considering until 5, it's going to be looks like this one, right? And we can get the slice from the index 2 to the end. So print looks like this, and get the slice from the start to the index 2. So print like this one. We can change the number. This, yep, looks like this one, and we can get the slice of the whole list like this kind of the operation. So the result looks like this, or we can get the slice in that the slice from the slice using the negative value like this one. So in this case, it's going to be from here to here. If we change the number, yeah, it's going to be looks like this. We can assign a new sublist to the slide, for example, like this one. Okay. We can loop over the element of the list like this. So let's make an animal list like this one by using the for loop. We can access each element. I mean each element in the list. So like this one. If we considering the one more class like what is that? Elephant. So the output is going to be looks like this. If we want to access the index of each element within the body of the loop, we have to use the built-in enumerate function. So it's very useful function. So in your project, I mean, in most of the project, you can use you might use this enumerate function. So what does it mean? So the syntax looks like this. So by using the enumerate function, you can extract the each element in the set as well as the index. I mean the index from 1 to the number of the element. So for example, if we have the list looks like this, by using the function of the enumerate, we can generate the index. I mean we can extract the index and the element. So if we remove this one, eliminate this one, the result looks like this. One more thing is that when programming, we frequently want to transform the one type of data into another. So as a simple example, considering the following code that compute the square number. So this is the number, and we want to transform this number to the square version of this one. So by using the for loop, we can implement this one like this. Let's think about let's say this case. I mean the x to the third. the result looks like this, right? It's very easy, but this for loop can be simplified by using a list comprehension defined like this one. So these two lines can be simplified like this, in this case, two. So the list x square for x in this list. So the output is going to be exactly same, right? And there are dictionary variable. The dictionary stores key and value pairs similar to the map in the Java or the object in JavaScript, but you don't need to worry the JavaScript. You can just understand this syntax. So dictionary is defined looks like this. So in this case, cat is key and dog is key, and values cute and fury are values in this case. So we get an entry from the dictionary like this one. This is the key. So we can find the values that have the cat key. So it's going to be the cute. If we change this one, something like this, it's going to be fury, right? Furry, what to say? Furry. And then we can check if the dictionary has given the key. So if the dictionary D have the cat key, then this one is going to be true, right? And we set the entry in a dictionary like this one, right? So yeah, there are a few more functions to get the element from the dictionaries like this one, right? It's very intuitive. So is there any questions so far? No? Okay. So let's keep going. It is easy to iterate over the key in a dictionary. Okay, let's say we have a dictionary looks like this. Person, cat, spiders, our keys, and 2, 4, 8 are values. So by using the for loop, we can extract the key. And then we can access them. We can access the values by using this key. For example, in this dictionary, the first key is going to be the person. So person here, and the values of the person is going to be 2. The second one is the cat. Second key is cat, and second value is going to be the 4. And so final one is the spider and 8. So this is the way to iterate over the key in a dictionary. Of course, we can make simpler this kind of the process by using the dictionary comprehension. They are similar to the these are similar to the list comprehension, but allow you to easily construct the dictionary. So the main difference are here comparing to the list comprehension like this one. So you can use this kind of the notation, but the operation are exactly the same like this. Or you can use the other number like this. Okay. The next two data type are set. A set is order the collection of the distinct elements. As a simple example, considering the following code. So this is the set. Set contains 2 elements, cat and dog, but main difference with this dictionary, it is the unordered collection of the element. So, for example, of course, we can check check if an element is in this set or not, and we can check the number of the element using this kind of function. I mean the length function, or add or remove the element in this in the set. And in iterating over iterating over a set has the same syntax as iterating over the list or the what's that dictionary. However, since set are unordered, you cannot make the assumption about the orders in which you visit the element of the set. For example, let's suppose that we define the set, I mean the animal set, as a cat, dog, fish, but you might assume that if we use this enumerate like this one, the order should be cat, dog, fish. But in the set data type, there's no order, so the output is going to be fish, cat, dog, like this one, or like this. So cat first and fish was the second one, and dog was the last one. So please remember there's no order in the set data type. Of course, like list and dictionaries, we can easily construct a set using the set comprehension, like this one. So this is the we can implement this kind of the concept using a for loop, but you can easily implement this one with one line by using a set comprehension. So this sentence means the range 30 means, okay, let me show you. So the range 30 means the list from 0 to 29. So anyway, so the values are from 0 to 13, but in this code, the integer of the square root of the x is going to be the same. For example, when you're considering the 0 and 1 and 2, the integer of the square is going to be same each other. So the output is going to look like this. But if we remove this one, I mean the integer 1, the output is going to look like this. Right? So yeah, this is the set comprehensions. 어렵지 않죠? 혹시 질문 있으신 분? 어렵지 않죠? 잘 따라오고 계시죠? 보면 정말 쉬워 보이고 실제로도 쉽고, 그래도 여러분들 오늘 강의 끝나고 한번 각자 다 해보시길 바랄게요. Okay, so the last data type is the tuple. So I mean a tuple, yeah. So we can call this one tuple. Tuple is an immutable ordered list of the values. So tuple is in many ways similar to list. One of the most important differences is that tuples can be used as a key in dictionaries as element is a set. So while list can't. So yeah. So here is a trivial example like this. So similar to the dictionary, it has the key and values, right? Yeah. So let me show you the dictionary. So tuple looks like this. So by using this rule, we can generate the tuple like this one. 0, 1, 0, x plus 1, comma, x, something like this, from x is equal to 0 to 9, right? Like this one. So the tuple, when you're considering the tuple, so looks like this. Tuple t is going to be the 5,6, and this type of tuple is it's going to be the tuple, and yeah, this dictionary, I mean this one, T dictionary, we can access the values in this dictionary by using the tuple like this one. So the values of this tuple is going to be 5. So 5 here, and the values of this tuple is going to be 1. Right? So this is the concept of the tuple. Similar to the other language, Python function are defined using okay, Python also have the function how to say the function module. So Python functions are defined using the diff keyword. Let me show you. So let's define our sine function. So in sine function, if x is larger than 0, so the function have to return the positive string, or if x is smaller than the 0, it should return the negative string, or otherwise it should be 0. I mean the 0 string. So by using a for loop, we can access this function and generate the output like this one. So this is the very simple examples of the function. Of course, every time you implement something, you may implement your function in your Python. Your Python code. So please try to make your idea as a function. So it's very important. One more concept is class. So if you are familiar with the C# or the JavaScript, the concept of the class is easy for you. But so if you're not, even though you're not, you don't need to worry about that. It's very easy. The syntax for defining the class in the Python is straightforward. So I will show you the example. Okay, so we would like to make a greeter class. So the starting of the class should be looks like this, and the class should have the initialization part like this one. The variable within this class is defined with this self. The self terminology. So something like the self.name is going is equal to the name, something like this one. And then we can make an instance method, the instance function within this class. So we are going to run something with this class. In this case, the greet. If the loud variable, if there is a loud variable, we want to make a hello. Capital output of the hello, or if not, we want to generate this hello. This hello sentence, and then we can define a class, or we can construct the instance of the greater class like this one. And then, okay, so if we first construct the instance of the general greater class, then you can first construct the initialization part, and then we can access the function or the instance method. Looks like this one, right? So g dot grade, or we can modify the input of this function. For example, like this one, right? So we can make more complex complex class like this one. So okay, so let me show something. So if we want to define the number, I mean the number variable, so define should be looks like this. So number, and so define the scale number. Number is going to be number, right? And the output is going to be number. Should be comma. Number. Right? So, for example, we can use the number like this one, and then access the function within the class. For example, like this one. With let's say yeah, okay, let me show you like this one. Yeah, okay, so it should be like this, right? So here, so here, so we can define the very simple function within this class. So in this case, the scale of the number. So in the initialization step, we define the number variable. Then we can just access the number like this one, or we can do similar things like this. Multiplication numbers. Okay, so let's get the another number. Okay, let's say number 2. Number 2, the output is going to be number 2. Then number 2 is going to be 1 in initial, but the number 2 is going to be, let's say, 2, like this one. Then, so by calling this function or within this class, we can just compute the multiplication between the set.number and the new number 2. So it's going to be 6, right? So this is the concept of the class. So, and then in our class, we will frequently, maybe always use the Numpy library. So Numpy is the core library for scientific computing in Python. It provides high performance multi-dimensional array object and tools for working with this array. So let me show you something. So by using a Numpy library, we can easily implement the array, let's say array functions, for example. Yeah. So like this one. So to use the NumPy library, we have to import like this one. Import NumPy as NP. So from now on, we can just the NumPy library, I mean the NumPy class as a NP dot like this, and then we can generate a new array like this one. And we can check the type of the array, and we can check the shape of the array and access each element or Yeah, so this is the actually this A variable is the vector, right? So I mean this is so it means that it is the rank 1 array or just vector, but we can also generate the matrix form like this one. So in this case, B is going to be the matrix form. Matrix form. So okay, let's show you this matrix. Where's that? Yeah, this matrix form. The shape of this matrix B is going to be 2x3 matrix, and we can access each element in the matrix. For example, 0, 0 is here. 0 by 1 is where's that? Here. 1 by 0 element here, right? So it's going to be 1, 2, 4. Okay. And NumPy also provide many functions to create the arrays, something like the zeros or the ones or the full or the i's. I means the identity matrix. So it create the identity matrix. So I2 means the 2x2 identity matrix. This random function create the array filled with the random values like this one. So when we calling this when each time so when we call this function, every time it generate the other values. I mean it make the other values like this one. It changes, right? And then similar to the Python list, NumPy arrays can be sliced. Since the arrays may be multidimensional, you must specify a slice for each dimension of the array. So, for example, let's considering this array. So the array A is going to look like this. Right? So this is a matrix form. Using slicing to pull out the subarray consisting of the first two row when the column 1 to n, I mean this one, and where is that? Until this one and this one and this one. So the subarray, I mean the subarray of the A, which was the P, which looks like this one. 2, 3, 6, 7. We can modify this one. Looks like this one, right? Yeah, looks like that's like this, right? And then a slice of an array each view into the same data, so modifying it will modify the original array. Okay, like this one. 그러네요. 이거 자 여기 해보면은 사실 볼 수 있어요. 자 여기 보면은 모듈 오브젝트가 콜럽을 하지 않다고 했는데 지금 보면은 우리가 2x2 매트릭스를 만들어내고 싶은 거잖아요. 2x2 매트릭스를 만들고 싶은기 때문에 여기서는 랜덤을 2번 쓰죠. 잠시 이렇게 보면 다시 돌아가 보면 2x2 매트릭스를 만들기 때문에 MP가 로우랑 컬럼을 따로 만드는 것 같아요. 제가 조금 이거 헷갈리는데 아마 그런 것 같은데 한번 확인을 해볼까요? 예를 들어서 우리가 2x1을 만든다고 치면 그래도 안 되네. 잠시만요. 그렇죠. 안 되는구나. 이거 잠시만 제가 이거는 확인해서 다시 알려드릴게요. 랜덤이란 모듈에 오케이. 맞아요. 맞아. 그러니까 MP라는 클래스 안에 랜덤이란 모듈 안에 랜덤이 또 있어서 한다는 게 맞는 표현인 것 같아요. 맞아요. 정우학생 고마워요. 맞는 것 같아요. 그러니까 MP라는 클래스 안에 랜덤이라는 펑션이 있고 그 안에 랜덤이란 모듈이 있고 그 안에 랜덤이 또 정의가 되어 있기 때문에 그렇게 불러야 되는 것 같아요. 오케이, 이거는 한번 저도 한번 다시 한번 체크해 볼게요. Okay, so where's that? Yeah. Okay, so you can also mix the integer indexes with the slice indexing. However, doing so will yield in an array of the lower link than the original array. So note that this is quite different from the way that method handle the array. So let me show you some. Let me show you example like this one. So okay, so let's show you the matrix A like this one. So the row R1 is going to be looks like this one. But if we use like this one, one dot two, one dash what to say? Yeah, 1,2. So it's going to be still the matrix form 1/4. So in this case, length 2 view of the second row of A, right? So in this case, it's going to be the vector, but this case, it's going to be still the matrix. So I'll just write this one. Similar things happens in the column space like this. Okay, so one more thing is that the integer array indexing, when you index into the NumPy array using slicing, the result array will always be a subarray of the original array. So in contrast, integer array indexing allows you construct the arbitrary array using the data from the another array. So let me show you the example. First of all, the array A is going to be the matrix, looks like this one. And an example of integer array indexing is like this. The returned array will have the shape 3,1 in this case. So it means that I mean the 0, 0, 1, 1, 2, 0, right? So 0, 1, 0, 1, 1, 1, and 2, 0 here. So it's going to be 1, 4, 5 here. And yeah, same things happens by using this kind of the line, like this one. And what else? Yeah, when using the integer array indexing, you can reuse the same element from the source array. So in this case, the matrix A here, 0, 1, it's going to be 2, and 0, 1, it's going to be 2 as well. So the output of this line is going to be 2 by 2. I mean the no, not 2 by 2, 2,2. And equivalent to the previous integer array examples looks like this one. Okay. So this is the integer array indexing. What else? We can also use the Boolean array indexing. Let me show you something. So our matrix A, it looks like this, but we want to access the element when each element is larger than 2. So first of all, we have to make a Boolean matrix like this one. So if A is equal to 2, I mean if A each element in A is larger than 2, the Boolean matrix looks like this one. First, true, right? So by using this kind of the syntax, a Boolean index, we can generate the output, which means the elements whose values are larger than 2. So in this case, 4, 3, 5, 6, right? 4, 3, 5, 6 here. So we can do all of the above in a single concise statement like this one. So this is going to be the Boolean index. Then output of this one is going to be 3, 4, 5, 6. The inverse things can happen like this, right? And next one is array math. Array math. Okay, so let's say we have a 2 array like this, x here, y here. We can add this one like this one, or by using a numpy function, np.add or the np.subtraction or the np.multiply or the np.divide function or the np.scale function, scale root function, like this one. Except for this kind of thing, there are so many functionality in the NumPy library. So please check the Python, the official Python tutorial that I mentioned before. And then one more thing is that in MATLAB, if you are familiar with the MATLAB, this notation was the element-wise. I don't know. I mean, it was the matrix multiplication, but in Python, this notation is the element-wise multiplication. So if you want a matrix multiplication, we instead use the dot function. Dot function to compute the inner product of the vector to multiply the vector by a matrix or to multiply the matrices. So here is the example. Our two matrix looks like this one. This and the vector v, vector w are like this one. Two matrix use what's that? V. This x w. Okay. X w v. Oh no, x y w v. Then by using a dot product, the dot function, we can compute the inner product of the vector between v and w, where the x and v. This case is matrix vector vector product and matrix matrix product. So if you remember our last lecture, in neural network, we frequently have to compute the matrix production or the matrix vector multiplication like this. So you have to usually use this dot function in our project. NumPy provides the many useful functions for performing the computation on array. One of the most useful one is the sum, like this one. The sum of this matrix is going to be 10. In this kind of case, what else? Yeah, there are transpose operator defined looks like this one, x dot t. So this is original matrix and this is the transposed matrix. One more beauty of the Python is the broadcasting. So broadcasting is a powerful mechanism that allows NumPy to work with array of the different shape when performing the arithmetic operation. Frequently, we have a smaller array and a larger array, but you want to use the small array multiple times to perform some operation on the larger array. So let me show you the example. Here is the matrix X, and here is the matrix V, right? But in some case, we want to add this vector to each columns of this matrix. For example, pull out this column, and this column independently. So so implement this one. So to implement this one, we might use the for loop to make a new matrix Y. It's going to be like this. So it just copy the same values. Where's that? Yeah. So in here, you might use the same vector in each iteration. So it's not a efficient way. Maybe you use the inherent function like the np-tile, maybe. Then you can copy the post. You can copy the same vector on the top of each other like this one. But it is also not efficient as well. So, but in Python, the NumPy broadcasting allows us to perform this computation without actually creating the multiple choices of the V. So here's the example. If we define the matrix X and vector V, then we can just add the vector matrix X and vector V. Then we can get a output like this one. So it's very powerful functionality in NumPy array or the Python. So it is the end of the NumPy library. I'd like to few more library. First one is the Cipher library. So NumPy provides a high performance multi-dimensional array and basic tools to compute with and multiply its array. Cipher library builds on this and provide a large number of the functionality that operate NumPy arrays and are useful for different type of the application. So part one is the image operation. We can easily read the images by using the imRead function within the this library. I mean the Cipher library. Then we can operate some some multiplication to the RGB value. So in this case, we multiply the green and blue channel by 0.95 and 0.9 like this one. And we can resize the original image like this one as a 300 by 300. Then we can also save the output image like this. So here's the example. So this is the original cat image. I mean, this is the original image, and this is the tinted image, like this one. So this is original one, and this is the tinted images. Actually, yeah, I will show you later. Anyway, and there are 예, 질문이 자료 안 올려줄 거예요. 이거 안 올려줄 거고 여러분들이 한 줄 한 줄 짜보시길 바래요. 정말 중요해요. 이거 아마 보면은 다 이해되는 것 같은데 본인이 짜보면 쉽지 않을 거예요. 그래서 이 코드들은 다 저희 강의 자료에 있는 코드들인데 아마 안 긁어질 거예요. 그쵸? 그림이라서 긁어지나? 안 긁어질 거예요. 그래서 이거 본인 컴퓨터에서 각자 한 줄 한 줄씩 본인이 타이핑해서 해보길 바랄게요. And one more functionality is the matplotlib library. Where you can easily generate the variable x and variable y and plot like this one. We can also use the cosine function. Looks like this one. One more thing is the subplot, similar to the matplotlib, like this. This is the okay. So we can generate the 2 by 1 by 1 subplot. Subplot matrix. So this one is the 1 by 1, 1,1. This one is the 2,1 case. So we can generate the two independent. We can visualize two independent plot on each subplot how to say, subplot space like this. Where is it? The last one is image. Okay, so we read the images and visualize the original image here and the transformed images here like this one, or using this like kind of this. You can change the how to say the colors of the original images. Like, for example, when we make the another number, it's like going to be like this one. Looks like this. Of course, we can make the another color images like this one. Okay, so this is the end of the Python tutorial. As I said at the first, it is impossible to look through the every Python how to say rule or the Python syntax. So I suggested you try to follow the official Python tutorial, and you can easily understand what it means. Okay, so yeah, this is the end of the Python tutorial. Before finishing, I would like to introduce our project one. Okay, so our project one is going to implement the two-layer neural network with the softmax classifier. We already talked about the softmax classifier and two-layer neural network. We have to perform the image classification using the Cypher 10 dataset. There are two weight and two biases. So we have to optimize these parameters, right? So predicted output is going to look like this. So please remember, we have the value activation function, not a sigmoid function. So if you remember our previous quiz, we considered the sigmoid function, but in this case, we have to use the value function. Please remember, and the total loss is going to be the softmax plus the log likelihood of the loss, or the softmax classifier with the L2 regularization. So in lecture 4, we already talked about the L2 regularization, but please remember, L2 regularization should be defined on W1 and W2, not the bias term, B1 and B2. And I gave you Python layout net Jupyter notebook code. So this Jupyter notebook, this notebook will work with you through the implementation of the two-layer neural network classifier. Okay, so before starting, you have to install some Python library, like this one, and we have to download the Cypher 10 dataset from this link, and unzip above the files to this link. This path. Okay. So, and then now you have the Jupyter notebook and some functional, the sum function. I already gave you the pre-implemented function, but you have to fill out the empty part in this function. Okay, then you will see this kind of the loss tendency, or the loss graph, or the visualization of our kernel, something like this one. I will show you. So this is the Jupyter notebook for our implementation. You can just follow the markdown cell and the code cell like this, right? Like this one. So this is the training loss like this. And okay, so to train the network, you have to load the data, but you already have the data part, so you don't need to worry about this one. But to train the network, we have to define our neural network, two-layer network. It is defined in this Python code, neural network py. So in this class, there is the initialization part and the loss function part and train function part. So you have to fill out this part and this part, this part, this one, and this one, this one. Oh, one more thing, this one, prediction function. And then you can see this kind of the loss tendency. If your output looks like this, and then looks like this, please check your code again. Might be wrong. Okay. And then one more thing is that you can tune your hyperparameter, like the regularization parameter or the what else, like the running rate. Looks like this hidden size, something like this. I gave you the very simple example, but you can do your hyperparameter tuning things here. Then find out the best performing network. So I just got a 0.39, but I guess you can do better than me. Okay. And then this is the end of the project one. Okay. So this project is due on the October 25 Sunday, maybe next week, right? So you have to submit this one in Blackbird with code and Leopard. Leopard should be one page with the free format. Leopard should be written in English. So I emphasize this one. Please do not copy your friend's one internet source. Please. We will check this one. So please remember. And please start your project early. Okay. So this is the end of today's lecture. Thank you for listening. So it's going to be the first project for you. So I think if you can success this project one, then you can easily follow the remaining projects like project 2, project 3, and project 4. Okay, so please take your time. Take your time to study the Python and to implement the project 1. Okay, thank you very much. See you next week. So 그 질문 있으시면 질문해 주시면 됩니다. 레트로 가기 전에 자, 이 자료는 지금 올라가 있고 와이드아스로 그건 다른 얘기인가요? 와이드아스로 가기 전에 랠리 한 번 더 안 해도 돼요? 안 해도 되고 파이썬 3.7 기준인가요? 3.8 호환되지 않는 게 있죠. 3.8 저도 3.7, 3.8 돌아가면서 쓰는데 큰 문제는 없었던 것 같긴 해. 호환 안 된 라이브러리 맞아요. 있는데 그거 그냥 지우고 돌려도 될 거예요 아마. 근데 혹시 안 되면 가상 환경 만들어서 3.7로 다운그레이드 해서 하는 게 나을 수는 있어요. 인라인 퀘스천. 네, 인라인 퀘스천도 적어서 제출해야 돼요. 이거 제가 저기 블랙보드에 좀 스페시픽하게 써놓을게요. 강의 자료 안 올라와 있나요? 이거 안 올라왔나? 잠깐만요. 올라갔을 텐데. 여기 있네. 여기 있어요. 이거 밑에 있구나. 여기 있어요. 이거 밑에 있어 보는 사람이 있겠는데? 여기 있어요? 우리 올려놨어요? 그리고 여기 말했구나. 오케이. 파이썬 파이가 수정되어도 수정되는 반영되지 않게 바꿨다. 이거는 여기에서 그냥 이걸 눌러주면 됩니다. 요거 이렇게 해서 커널을 리스타트 해주면 돼요. 정민 학생. 그리고 what should we include the project? Okay, so Kevin, I will let you know the project 1 leopard specifically in Blackbird. So please check this one. And 레포트도 정말 자유형식이에요. 레포트 정말 자유형식이고 여러분들이 이 프로젝트를 해보면서 얻은 파인딩 또는 뭐 어떤 식으로 진행을 했는지 임플리먼트 디테일 어떻게 됐는지 자유롭게 적어주면 돼요. 네. Okay, so is there any other question? 오케이, 그래서 제가 아까 말했듯이 너무 중요한 거고 이제 다음 시간부터 얘기를 하겠지만 사실 프로젝트 2부터는 우리가 저 로스 그레디언트를 사실 계산할 필요도 없어요. 제가 나중에 얘기하겠지만 파이토치라는 이제는 우리가 라이브러리를 쓰기 시작하면 이제 그레디언트 업데이트하는 것도 다 해주기 때문에 사실 안 해도 돼요. 그래서 이제 많은 학생들이 심지어 많은 대학원 학생들까지도 저 로스 그레디언트를 손으로 한 번도 해보지 않고 그냥 있는 라이브러리를 써서 딥러닝들을 구현한 학생들이 정말 많아요. 그런데 이제 제가 첫 시간에 얘기했듯이 그렇게 하면 정말 사상 누각이에요. 파이썬 딥러닝 시대로 오면서 파이썬도 정말 쉬워졌고 그렇기 때문에 구현도 정말 쉬워졌지만 그렇기 때문에 우리가 그 밑에 이 쉬워진 이유가 정말 많은 연구자들이 잘 좋은 라이브러리들을 만들어 놨기 때문인 거죠. 뭐 넘파이, 뭐 파이토치, 뭐 텐서플로우 이런 것들을. 근데 그 안에 어떻게 돌아가는지를 이해를 못하고 그걸 쓰다 보면 정말 그 퍼더를 나갈 수가 없어요. 그래서 첫 번째 프로젝트가 그런 의미에서 정말 중요하고 아주 간단한 네트워크예요. 레이어 2개밖에 없을 거고 이거 한번 손으로 자기가 다 풀어보고 한번 구현을 해보면 이제 다음 프로젝트들을 진행하고 이제 여러분들이 뭐 어떤 분들은 대학원을 가는 친구도 있을 거고 회사를 가는 친구도 있겠죠. 아마 많은 학생들은 딥러닝을 임플리멘테이션을 쓸 거예요. 그렇죠? 정말 도움이 될 거라고 확신합니다. Okay? So take your time to do this project one. Okay, so this is the end of today's lecture. Thank you for listening. Let's see next week.